Alright, welcome to part 2 of today's lecture. So in the last video, we discussed the electron current, what's actually happening inside of your wires when electricity flows. Electrons are moving, not in a nice straight path. That's for superconductors, which we're not getting to in this class. But, alright, it's moving in a general direction due to an electric field. Now we want to talk about current, how we measure it, typically for real purposes, because it's not very beneficial to look at drift velocity, the number of electrons, all of that. It's hard to measure, and we need a better way to do so. So let's consider the current to be the rate at which electrons move. It is defined as such, so current being capital I, it is defined as the change in charge over the change in time. How much charge moves in a time. That is what the current is. The SI unit is the ampere, which is a coulomb per second. Coulomb being the unit of charge, or the SI unit for charge. Time is still in seconds. Now for a steady current, which is what we are going to be using in this class, so that means a nice constant current that doesn't change over time, you can rewrite the current equation as charge is equal to current times the change in time. So we need to talk about something that's kind of, it's related to electron current. Conventional current, which is this I here, it is related to the electron current by just taking the electron current, multiplying it by charge. But the charge here isn't negative. It's positive. And that's because for some reason that I still don't quite understand. The textbook tries to explain it, and I'm going to try to talk about it. With electron current and current, they are closely related, equation-wise in their understanding. However, in my opinion, I think it's due to tradition. Other people might have other opinions. When we are discussing current, it is defined based on the motion of positive charges. So let's go back a little bit. Before we understood how exactly the atom worked, we as a group, or we as, I guess, physicists, and I'm not sure how heavy electrical engineering existed at the time, it was believed that positive charges are what moved. Because of this, all of the rules and all the ways that the equations are formulated are based off of positive charges. Is that correct? No. However, it does give us a couple of nicer things to look at. When you're dealing with current, you're going to be dealing with conventional current, which is the positive charge. To know what is really happening for current, you just change the direction. The math works out exactly the same because the math was done on electrons without knowing the direction. So math is the same, it's just flip the direction. That's the actual way in which the current flows. So by using positive charges, the current moves in the same direction as the electric field, but in the opposite direction of the electron. So what that looks like is this. So here we have our wire. We have our electric field, in this case pointing to the left by these pink arrows. And we have the positive charges moving to the left, that is creating the conventional current, which is drawn on the top here. So if you know the direction of the electric field, you can find the direction of the conventional current. They're in the same direction. And to find the direction of the electron current, you just flip the direction. Mathematically, when you go through and look at circuit math, it's not going to matter. When you set it all up and everything, it'll be set up for conventional, but it's mathematically explaining electron motion. So you just flip the direction, call it a day. We'll talk about that more when we get into circuits next lecture, but that's next lecture. We have a lot to look at for that without necessarily solving, but we'll get there next time. So let's just push off kind of what's going on with why and what this means till a little bit later. Just know that when we are using capital I, we are talking about current, it is the positive charges that physics is looking at. If you see electron current, it is the current for electrons. So that's it for this video. The next video, we're going to look at how do we take that moving electron and build it up into something that we can use to actually calculate currents as we do today. For that, we need resistivity, resistance, and Ohm's law.